The fundamental counting principle says that if there are m ways of doing one thing and n ways of doing another thing, then there are m times n ways to do both things. So based off this definition, let's check out a few examples of how we can use the fundamental counting principle to solve word problems. Alright, this problem says your closet contains 3 different shirts, 2 different pants, and 2 different jackets. How many different combinations of outfits can you form if you choose 1 shirt, 1 pair of pants, and 1 jacket? So one way to apply the fundamental counting principle to solve this problem is we could actually write out every single possible combination in what's known as a tree diagram. So remember, it says there are 3 different shirts. So let's say we could choose shirt 1, I'll label it as a little 1, or we could choose shirt 2, or we could choose shirt 3. Now, if we choose shirt 1, to go with that, we could choose, remember there's 2 different pairs of pants. So we could choose, let's say, pants number 1, or we could choose pants number 2. Now, if we choose shirt 1 and pants 1, to go with that, we could choose then, there's 2 different jackets. So we could say we could choose jacket 1, or we could choose jacket 2. But if we choose shirt 1 with pants number 2, well, along with that, we could also choose either jacket 1 or jacket 2. So we can go through all of these possible combinations and write out every single possible combination. So if we choose shirt 2, we could choose pants 1 or pants 2 to go with it. And with either of these pants, we could choose jacket 1 or jacket 2. So if this one, we could also choose jacket 1 or jacket 2. And then if we choose shirt number 3, we could also choose pants 1 or pants 2. And with pants 1, we could choose jacket 1 or jacket 2. And with pants 2, we could choose jacket 1 and jacket 2. So we're getting a little tight on space here, but that's okay. So if we want, we can literally just count out all the possible combinations. So one possible combination is shirt 1, pants 1, jacket 1. That's one possible combination. I'll just circle the jacket. Or we could choose shirt 1, pant 1, jacket 2. Or we could choose shirt 1, pant 2, jacket 1. Shirt 1, pant 2, jacket 2, and we can just go through and circle all of the possible combinations that we could choose. And we'll find that the total number of combinations is 12. So that's our answer. There are 12 different combinations of outfits that we could choose. Now, another way to do it, and perhaps an easier way than drawing out this tree diagram, is simply to multiply the number of ways of doing each task. So there are 3 different shirts, 2 different pants, and 2 different jackets. So all we really have to do is 3 times 2 times 2. So 3 times 2 is 6, times 2 is 12. So that gets us the same answer by just multiplying the total different number of ways that we could do each task. Let's check out this example. A license plate must have 3 letters followed by 3 digits. How many different license plates are possible if letters and digits cannot be repeated? So I've drawn out 6 spaces here for this license plate. And we know that for these first 3, I'll label it L, L, and L, these 3 have to be letters. And then it has to be followed by digits. So let's write D, D, D. So for this very first letter right here, there are 26 letters in an alphabet. So there are 26 different choices for which letter you could choose. So you could choose an A, a B, a C, all the way up to Z. Now, once you have chosen a letter for this very first position, in this next position, there are only 25 choices left for what letter to use. So for example, if you chose an A for this position, then that means there's only 25 other letters that you could choose for this one because we're not allowed to repeat letters. And similarly, once you've chosen the letter for this position and this position, then this next position, there are only 24 choices of letters that you can use because let's say you chose an A and a B, you're no longer allowed to choose A and B for this position. So there's only 24 choices left in the alphabet for you to choose. Now, for the digits, we kind of repeat the same process. So the first digit, it can be anything from 0 through 9. So you could choose 0, 1, 2, 3, 4, all the way up to 9. So there are 10 total choices for the digit. So we'll say 10 choices for this one. Now, once you've chosen the digit for this position, the next digit, there's only 9 possible choices. Because remember, the digits cannot be repeated either. So now once you've chosen a digit here and a digit here, there's only 8 possible choices left for this last digit right here. So the way that we find the total number of license plates is we just multiply each of these values together because these are all the different combinations that you could choose. So if you punch 26 times 25 times 24 times 10 times 9 times 8 into a calculator, you get 11,232,000. That's how many different license plates are possible if the letters and the digits cannot be repeated. All right, let's try one last example. This one says a baseball manager is setting the batting order for his team. The team has 9 players, but the manager already knows he wants the pitcher to bat last. How many batting orders are possible? So I've drawn out 9 possible slots right here for each position, and it says that the manager knows that the pitcher needs to be last. So we'll put a P right here. This last player right here, this has to be the pitcher. So that means there were 9 players, but now that we know the pitcher's position, there's only 8 players left to choose from. So in other words, the very first batter, so this position right here, there are 8 different people that he could select to be the first batter. Now, once he has chosen one of these 8, then for the next position, there's only 7 possible players that he could choose from. And then after he's chosen both this one and this one, there's only 6 possible players left to choose to bat in this position. And then after that, there's only 5 possible players left for this position, then 4 for this position, 3 for this position, 2 for this position, and once he's chosen all of those, there's only 1 person left to choose for this position. So to find the possible number of batting orders, again, like the last example, we just have to multiply all of these values together, because this represents all the different ways that we could choose a batting order. So if we do 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, we get 40,320. That is the number of different batting orders that are possible given this scenario. So those were just a few different examples of how you can use the fundamental counting principle to solve word problems.